The upstream oil and gas industry operates a large number of diverse machinery, some of which is rotating, like pumps, compressors, gas turbines, some of which is not rotating, like heat exchangers and valves and reactors. All these equipments need to be maintained. Some maintenance is planned and some is unplanned due to failures. We want to know in advance when these failures will take place so that we can better plan our maintenance efforts, our spare part orders, and our personnel. To do that, we currently use condition monitoring, which has a bottom limit and a top limit for every single measurement. However, this technology is unfortunately not very successful because it produces a very large number of false alarms where these bottom and top limits are briefly crossed and I get an alarm, but that's not a genuine problem with the machinery. That causes some effort because these alarms, of course, have to be checked. The far more serious problem is what I call missing alarms, which is when I do not get an alarm from condition monitoring, but the machine is in a bad state nonetheless. That happens when various conditions come together. The parameters may go high, but not cross the limit, but because of a combination of various sources, I still have a problem. Through the technique of machine learning, it's possible to take all the data around an equipment and look at it holistically, to make a model for that equipment and to make a genuine prediction into the future of what that state will look like in 1 day, 2 days, 1 week, and so on. And therefore come up with a genuine prediction of when that equipment will fail. That technology is very successful. It has about a 95% hit rate and therefore produces far fewer false alarms, and it catches the instances where the machine is unhealthy due to various combinations of factors, and therefore provides you with a very reliable and accurate alarm that you can then go away with and actually do something about it. It's known that a catastrophic failure in terms of collateral damage as well as production losses costs 10 times as much as repairing the problem before it gets to the failure. Therefore, predictive maintenance is a very lucrative methodology to implement, especially in the upstream oil and gas industry. We've created a software called the Intelligent Health Monitor that you can install in your plant within 2 days and have operational soon thereafter by just including some historical data, training the models, and then it will provide you with alarms. It works for all manner of rotating and non-rotating equipment. We invite you in a pilot phase to try this out in your very own plant and to come to grips that indeed predictive analytics and predictive maintenance are for real. Thank you.